All right, objective 3 here. Again, let's get right into the example. Example 3 is this lottery fair to all pilots. So an airline has just finished training 25 junior pilots, 15 male and 10 female, to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced that they will use a lottery process to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper, placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. Okay, so this is a combinations situation because it doesn't matter who gets drawn first, second, third. It's just all about getting 8 people. So it says a day later, managers announced the results of the lottery. Of the 8 captains chosen, 5 are female and only 3 are male. Some of the male pilots who were not selected suspect that the lottery is not carried out fairly. So again, why would they have any beef with how the lottery is carried out? Well, I think it has to do with the total number of each gender. There were 15 male and 10 female. There are more males than females. So I think they assumed that when the 8 were drawn, there'd be at least one more male than female drawn, right? So a 5-3 breakdown the other way, but it wasn't. So again, they have some concern. So let's use some probability to figure this out. So it says find the number of ways in which the fair lottery can result in 5 female and 3 male pilots being selected. So this problem is going to build. There are 3 parts. So when it says find the number of ways, that is not a probability problem. That is just a simply number of ways problem. So there are 5 female, 5F, 3 male. So how many ways can I choose 5 female and 3 male out of 15 males and 10 females? Well, to choose 5 females, I take my 10 females and I choose 5. And I multiply that by taking my 15 males and choose 3. And I'm going to multiply this in Desmos graphing calculator and get an answer of the number of ways. Okay, so NCR, I'm doing 10 females, choose 5, times NCR, I'm doing 15 males, choose 3. And I got 114,660, and that's how many different ways there are for this result to happen. That's our part A. Part A. Okay, part B. So now it says find the probability that a fair lottery will result in the selection of 5 female and 3 male pilots. So to find the probability that there are 5 female and 3 male, we're going to use our answer from part A because that's the total number of ways, right? That is the 10 females choose 5 times the 15 males. Sorry, let me slow down. So the top is going to be the number of ways. So the 10 females choose 5 times the 15 males choose 3. So our top is going to be that 114,660. This is why it builds. But the bottom is going to be the total number of ways that you can choose 8 captains or 8 pilots for the 25 positions. So that's 25, choose 8. 25, choose 8. So I'll type this into my calculator. Okay. And this is going to be the probability. So we will do 114,660 divided by NCR, and that was 25, choose 3. I'm sorry, choose 8. And there we go, I'll round to 3 decimals, so 0.106, the 0 after the 6 keeps it the same, so 0.106, that's your probability. This is my answer to part B. Okay, and then part C asks, based on your answer to part B, is there convincing evidence that the lottery wasn't carried out fairly? Explain. So I'm going to write 2 sentences. I'm going to say that there is about a 10.6% chance of a fair lottery And I just said of a fair lottery, but you can use whatever wording you want to. I'm going to try to bring this into here. So there's about a 10.6% chance of choosing 5 female and 3 male junior pilots for the 8 captains positions. There is about so this is me just stating the probability. There is about a 10.6% chance of choosing 5 female and 3 male junior pilots. Sorry about that word junior. Junior pilots. That was me thinking instead of just writing. Junior pilots for the 8 captains positions. So we compare that to 5%. That's greater than 5%. So this can happen too often by chance. Therefore, the disgruntled males have no basis, have no convincing evidence that the lottery wasn't carried out fairly. Therefore, there is not convincing evidence that the lottery wasn't carried out fairly. There is not convincing evidence that the lottery wasn't carried out fairly. And that is, again, because 10.6% is greater than 5%. Okay? So again, these male pilots who did not win the raffle, so sorry, but you have no probability basis to stand on. All right, good luck on the homework. Again, this last objective is the most important part of these last 2 lessons, 4.7 and 4.8.